Hello, everybody. My name is Brantley from the General AI Proficiency Institute, and here is a quick AI lesson that I'm going to do. I'm trying to do these like less than 5-minute lessons on AI and showcase them to everybody and put them on YouTube and wherever else. So like and subscribe if you like this type of content, and I'm going to go ahead and jump right in here. And so today's lesson is going to be about memory, how AI harnesses use memory, and what that looks like. And I put together this little application here through Replit, of course, to kind of showcase this. So what's the problem with memory and AI? You've probably heard, back and forth on, memory sucks for AI and they forget things and whatever. So the problem is there's so much information that you want the AI to understand, that how do we get it to understand that? And it does have a finite context. Context is the amount that you can put into like one prompt with an AI, and there are limits to that right now. And as the models get bigger, that limit is getting bigger as well, but it's still a problem. And so the problem is you have a million books in a giant pile, and it looks like this. And we want to feed these large documents to AI. We want them to understand it. Of course, it's been trained on billions and trillions of parameters, but in the moment, we want it to understand things that we need it to understand. And so, you imagine this massive library of millions of books, and we're asking the AI to find a single paragraph within this massive library of, let's say, and we'll use the example that it made here, a wizard using a wand. And so, obviously, if you're going to try to read every single book, if you have a million books and you're trying to find a paragraph about a wizard using a wand, that's going to take forever. And so AI faces this exact same problem with a bunch of large documents that you either give it or you've given it over time. It needs to be able to somehow, nail down a specific piece of a specific file, of a specific, piece of information. And so we don't want it to have to reread these millions of pages throughout these millions of books, every time you ask it a question. So what's the solution? And essentially, what it breaks it down to is there's a process within AI memory, and we use this within our own Jenna platform, and it's called the brain piece of Jenna, which it's called that right now. We might change the name of it, but essentially, I'm trying to explain this as how do we take these millions of books and then turn it into something that the AI can effectively look through and find without having to put those millions of books within that finite piece of context that it can take within every question. And the first step to doing this is called chunking. And chunking is essentially where you're kind of like ripping pages out of the book and you're chunking it into more finite, easy to read and understand chunks, essentially. So you don't have it read the entire book in one sitting. You basically chunk it down into more manageable pieces, and that's what chunking is. And so that's the first piece that happens, in Jenna when we want it to, when we give it a bunch of documents and we want it to add that to the brain. The first thing it's going to do is it's going to chunk those documents, those 100 pages of documents, going to chunk them into more manageable pieces, which might be 2 to 3 paragraphs or so, for example. So that's the first step in order for AI to understand, data easier, to get data faster and easier. The next step is vectorizing. Vectorizing is where, AI does not understand English. For what it might appear to be, AI does not understand English. It understands math. And so the next step is to take those chunks and then to vectorize them and turn them into essentially math coordinates. And so you can see here in this example, dog and puppy show up pretty close to each other because they're similar ideas. Cat is a little bit outside, but it's still an animal, so it's kind of close. And then you have car, which is, a mechanical thing that was built by humans, and so it kind of pops up over here on the graph. And so that's essentially what AI is doing when it's vectorizing. It's taking words and assigning them mathematical numbers or vectors, and putting them onto this vector kind of graph, situation. And so you can see here with this example, it kind of makes sense. Ideas that are similar get assigned similar numbers or vectors, and then that allows the AI to kind of compartmentalize these number or these words into something that it can go find a lot quicker. So first step is chunking. You take a lot of information, you chunk it into more manageable information, and then you go and vectorize every word within that chunk to then put it into a nice mathematical graph for an AI to understand. And then the next is it embeds it. So the embedding is another piece. AI does do embedding. That's the next step after vectorizing. And embedding is essentially where it organizes the knowledge, by the meaning. It's vectorized to keep like items close on the mathematical graph. And now it's actually taking all of that knowledge and all those different vectors and putting them together in groups so that it's even quicker at going and finding. If the user asks about an animal, it can go find, if it asks about a dog, it can go find the dog in wolves, or dogs are similar to wolves. And so that's all categorized in a certain knowledge, organized into a knowledge kind of group. And then you have cars, computers, these different examples right here, as you can see. And so essentially, when you ask a AI, hey, I'm talking about a dog, go research me on some stuff on dogs, based on the information that I've given you. Maybe you fed it a bunch of books about dogs, or just animals in general. And it's going to go and find that embedding. It's going to be like, okay, he's talking about dogs in this particular question. I'm going to check that, what about dogs? Oh, I want to know how big the dog is, or how big a Rottweiler can get. And so basically it's going to go into that embedding, go to dogs and wolves, for example, like in the example here. And then it's going to say, okay, he wants to know how big a Rottweiler is. So I can go into my vectorizing, I can find the word Rottweiler, it's really close to dogs. And then I can go to the chunks and find where Rottweiler is mentioned, and probably the size would be there. And it does this within milliseconds, obviously, all this thinking, but it helps the AI be able to compartmentalize. So within Jenna, within our own AI harness, a brain is this embeddings, essentially. That's what the brain is building when we add documents to it and we have it build its brain. That's what these chunks, these vectorizing, the vectors, the embeddings, all are the brain. Within Jenna as well, and within a lot of AI harnesses, they have a memory. And the memory is just, short-term memory, where it's just documents that it takes every time. So that's the difference between the brain when we get to these like embeddings. And then you have the memory, which is a lot of, OpenClaw uses a memory.md. I'm sure Claude does. I'm sure ChatGPT does. And this is a file that it's going to take into context every time you ask it a question. So obviously we don't want this memory.md file getting super huge, because that takes a lot of your context that you have available for the AI to then, take in more information. And so the memory.md is used for things like, who are you? What name does the AI go by when you talk to it? These are the types of things that it puts in kind of like its short-term memory for this memory.md document. So that's the difference between what like a chunked, vectorized, embedded brain would be, as opposed to a short-term memory file, where it takes this into account every time you ask it a question. This memory file is taken into account, and it's read fresh every time. It's not going to go read a million books every time you ask it a question to refresh its memory on that. That's what it's going to go use, those chunks, vectors, and embeddings, to go then dig down and get into the nitty gritty of what you've asked for, once it understands what you're asking for. If I ask for a Rottweiler, what's the size of, what can I expect a Rottweiler to get to in size, it's going to go dig into that brain and find that information for me. Whereas the memory.md document is going to get read immediately, so it knows, oh, this is Brantley talking to me, and I'm Jenna, or whatever you name your AI, and I work for a business. Those types of things are in the memory file. So that is what I wanted to explain here. I think I went a little bit over time, but and anyways, I hope you understand memory better for AIs. And this is Brantley with Gen AIPI, the General AI Proficiency Institute, and hope to see you again.